Hello everyone, welcome to the channel Top Gate. In this video, I'll discuss one more solution to the critical section problem involving two number of processes. In the previous lecture, we have seen the solution to the critical section problem involving two processes only. And in that one, we have used a simple shared variable turn. In this one, we'll again see a solution for the critical section problem involving only two processes. But in this one, we will be using a new variable, a Boolean type array type of variable. Clear? So let's assume that there is a shared variable, okay, and this shared variable is you can say its name is flag, and it is the array type of variable having only two elements. Okay, so flag 1 and flag 2, and it is of Boolean type. Clear? That is, it can have only two values, true or false. So flag 1 can be true or false, flag 2 can be true or false. So let's assume that initially the values of flag 1 and flag 2 both are false. Okay, so I'll write it here. So initially flag 1 is set to false and flag 2 is also set to false. So what does that mean? Flag 1 is equal to false means right now P1 is not willing to go to the critical section, or it is not P1's turn to go to the critical section. And flag 2 is equal to false means P2 is not willing to go to the critical section, or it is not P2's turn to go to the critical section. So let's write the solution. So we have two processes, P1 and P2. So I'll write a code for P1 and P2 both. Clear? So this is the code for P1 and this is the code for P2. Now let's see whether all those three requirements are satisfied or not. So one by one we'll see. The first requirement is the mutual exclusion. So whether it is satisfied or not, let's see it. So initially we'll see that process P1 and P2 are coming in a serial way. That is, P1 is coming first and then P2 is coming. And then we'll see that P1 and P2 are coming together and they want to go to the critical section together. Okay. So the first scenario, P1 is wanting to go to the critical section first, and then P2 will go at the second position. So initially flag 1 is equal to false, flag 2 is equal to false. So what P1 will write? P1 will write while flag 2 is equal to true, do skip. And what is the value of flag 2? Flag 2 is equal to false. Therefore, this while loop will be broken since it is not true, and it will go to this instruction. And in this instruction, it will write flag 1 is equal to true. So flag 1 was false initially, and now it will become true. Okay, so after making it true, it will go to the critical section and start executing into the critical section. Clear? So the process P1 is working in the critical section. At that moment, P2 comes and it also wants to go to the critical section. Okay, so what it will write? It will write while flag 1 is equal to true, do skip. And what is the value of flag 1? Yes, flag 1 is equal to true. Therefore, this while loop will not be broken. It will continue to skip in the while loop. It will not be able to execute this particular instruction. Therefore, it will be stuck in the while loop only. Clear? Now, P1 who was working in the critical section, after completing its work in the critical section, it will come out, and in the exit section, it will write flag 1 is equal to false. So now the new value of flag is equal to false. As soon as this flag 1 is equal to false, this P2 who was stuck in the while loop, this while loop will be broken. Why? Because while flag 1 is equal to true, do skip, and the value of flag 1 is not true. Therefore, it will stop skipping and it will execute this second instruction, and it will do flag is equal to true. Therefore, this false will be changed to true, and it will continue to execute in the critical section. So in this scenario, we can see that mutual exclusion is satisfied. Clear? Now let's assume one more scenario in this one. Suppose P1 and P2 both are coming together. Clear? P1 and P2 at the very same moment they want to go to the critical section. Clear? So we'll see side by side both these codes. So initially let's change the values. So initially the value of flag 1 is equal to false, the value of flag 2 is equal to false. So P1, while flag 2 is equal to true, do skip. It will write while flag 1 is equal to true, do skip. Clear? And the value of flag 1 is false, the value of flag 2 is equal to false. Clear? Therefore, the while loop of both these P1 and P2 will be broken. Clear? And they both will go to the next instruction. So in the next instruction, they will write flag 1 is equal to true, flag 2 is equal to true. So right now, the value of both these flag 1 and flag 2 becomes true. True here also, true here also. Okay? And they both simultaneously will enter into the critical section. Clear? Therefore, in this solution, mutual exclusion is not guaranteed. Hence, this solution is a wrong solution. Clear? That is, they both can enter into the critical section. So, there is no point of checking whether progress is satisfied or not. Since ME is not satisfied, therefore, we will not check for progress and other requirements. So, let's change this a little bit and see whether this mutual exclusion can be satisfied or not. So if we change a little bit, just a small difference we have to make in this one. That is, this statement, whatever we have written here, we can do it here. So let's write it here only. That is, flag 1 is equal to true. So flag 1 is equal to true here, and I will remove it from here. Okay. So this is your entry section for P1, and similarly here also I'll simply just change this. Okay, I'll write flag 2 is equal to true, and this is your entry section for P2. So just a small change we have done. We have done flag 1 is equal to true was written here. I have just shifted it to the very first statement. And here also flag 2 was written here, and I have just shifted it up here at this point. Clear? Now let's see whether this mutual exclusion is satisfied and progress is satisfied or not. So let's change these values. Flag 1 is equal to flag 1 is equal to false, and flag 2 also is equal to false. So initially both the values of flag 1 and flag 2 are set to false. Clear? Now let's see whether mutual exclusion is satisfied or not. So P1, for P1 we have the first statement is flag 1 is equal to true. So what it will do, it will set the value of flag 1 is equal to true. So initial value was false. Now the new value, it will be changed to true. So the new value of flag 1 is equal to true right now. So flag 1 is equal to true. After making it true, it will execute the next statement. Next statement is while flag 2 is equal to true, do skip. And what is the value of flag 2 right now? Flag 2's value is false right now. Therefore, this while loop will be broken and it will go to the critical section. Clear? So while it was executing in the critical section, P2 comes. P2, it will write flag 2 is equal to true. Okay, so flag 2 is equal to true, so this will be changed to true. Okay, and then it will execute while flag 1 is equal to true, do skip. And what is the value of flag 1 right now? Flag 1's value is true right now. So therefore this while loop will not be broken. It will continue to skip in the while loop. Clear? And it will not be able to go to the critical section unless and until P1 comes out of the critical section, sets the value of flag 1 is equal to false, then only P2 will be allowed to go to the critical section. So in this one, mutual exclusion is satisfied. Clear? Now let's take another scenario. So another scenario can be, let's change the values first. So initial values of both the flags are set to false right now. So next scenario can be P1 and P2 both are coming together. So P1, what it will do? Flag 1 is equal to true. P2, flag 2 is equal to true. So the values of both the flags will be true in the very first statement. Okay, so both are trying to execute at the very same time. So flag 1 is equal to true, flag 2 is equal to true. P1 will execute while flag 2 is equal to true, do skip. It will execute while flag 1 is equal to true, do skip. And what is the value of flag 1 and flag 2? The values of flag 1 and flag 2 both are true right now. Therefore, both P1 and P2, they will be stuck in the while loop. They'll continue to skip and they will not be allowed to move to the critical section. Why? Because the values of flag 1 and flag 2 both are set to true. Therefore, P1 and P2, they will not be able to go to the critical section. Hence, the system is not able to do progress. It will be stuck at this moment and no one will be able to go to the critical section. So indirectly, P1 is dependent on P2, that P2 should go to the critical section, sets the value of flag 2 is equal to false, then only P1 can go to the critical section. And P2, it is indirectly dependent on P1, that P1 should go to the critical section and change the value of flag 1 is equal to false, and then only I can go to the critical section. So this is not progress. The system is not able to do progress. Hence, mutual exclusion is satisfied in this case, but progress is not satisfied. Clear? So for the second solution, we have two variants. In the first variant, mutual exclusion was not satisfied. In the second variant, mutual exclusion was satisfied, but progress not satisfied. Hence, this solution is also not correct. Clear? So in the next video, I'll try to give you one more solution, and then we'll see whether that solution satisfies all those three requirements or not. Clear? Thank you so much.